The fourth module of this course deals with logical database design and the relational databases. The purpose of Chapter 4 is to describe in detail the major steps in logical database design, with an emphasis on the relational database models. Logical database design is the process of transforming the conceptual data model, which is discussed in Chapter 2 and Chapter 3, into a logical data model that can be used to develop the tables in a relational database. This chapter will first provide a description of the relational data model, which is the most popular data model being used today in the business environment. Understanding the terminology and concepts related with relational database, such as relation, attributes, primary key, foreign key, and referential integrity is very important. The chapter will then provide a description and illustration of the various types of integrity constraints associated with the relational model. This section introduces SQL table definitions and the concept of well-structured relations. We will then provide a detailed description of the process of transforming enhanced ER diagrams into relations. Next, the chapter will define normalization and describe the steps in normalizing relations so that all the tables are well structured and without any possibility for anomalies. The chapter will conclude with the discussion of merging relations and techniques for dealing with typical issues that arise during the normalization process. So there are two key topics in this chapter. The first key topic of the chapter is transforming enhanced ER diagrams into relations. At this point, you should realize the importance of drawing a good ER diagram during the analysis phase. The relational database is designed based on the enhanced ER diagram, and you will find many guidelines for transforming the enhanced ER diagrams into relations in this chapter. For example, how to deal with a many-to-many relationship in the ER diagram, how to deal with multi-valued attributes, how to deal with the bill of material scenario, and so on. You do need to memorize these guidelines for transforming the enhanced ER diagrams. The best way to memorize them is by working on the assignment problems that I have given you. You can also try to work on some of the other end of chapter exercises to see if you are able to transform enhanced ER diagrams into relations in different scenarios. Please make sure that you completed the assignment so that I can provide you with timely feedback. The second key concept, normalization, refers to breaking large relations into multiple smaller and well-structured tables. The purpose of normalization is to get rid of any possible anomalies that may exist in the logical data model. You need to be able to identify the different types of anomalies caused by relations that are not normalized. The process of normalization is straightforward and not a difficult one. A lot of the students, however, are not clear about why we need to normalize tables. Well, in a perfect world, if a database designer starts a database project from scratch, does a perfect job creating enhanced ER diagrams, and then transform the ER diagrams into relations following the guidelines perfectly, normalization may not be a necessary step because all the relations should already be well structured. However, in the real world, this is an exception instead of the norm. In most real-world situations, a database project often involves upgrading an existing paper-based system, file processing system, or an outdated or poorly designed database system. The project may also involve integrating multiple data sources into one enterprise database. So in all of these situations, normalization is absolutely necessary to ensure the integrity of the database. The reading assignment, the article Third Normal Form Frequently Asked Questions, covers some practical issues related to normalization that people run into in their database projects. Although some of the concepts discussed in the article refers to data warehouses, which will be covered in the future module, they are still applicable to database in general. At the end of this module, you should have accomplished the following learning objectives. First, you will understand the terminology and the concepts related to relational database, which is the most common type of database that you are going to encounter at work. So understanding the terminology and the concepts will be very useful when you are involved in a database or application development project in the future. Second, you should be able to transform enhanced ER diagrams into relational tables. That's a key step in developing databases. And the skills to do that will be very useful when you transform a database concept into an actual database that is functional. Third, you will perform normalization on relational tables that are not well structured. And as I described before, many projects in the real world will come with large tables that are not well structured. And understanding how to normalize tables is a very important skill in order to build databases that are not going to cause integrity problems in the future. The written assignments for Chapter 4 of the main textbook that I have assigned to you should be very helpful for reviewing the most important topics covered in this module. So please complete the assignment and submit them on time so that I can go over the common mistakes found in your assignment with you after grading them.